Hi, welcome to my video. I'm relating the exponent and the log rules. But before I start the video, I want to do a problem that I didn't do on my video 16. On video 16, page 5 of 5, number 5D, I have this problem that I didn't do. The log 2 equals x, the log 3 equals y, the log 5 equals h. Express the log of 4 over 125 in terms of x, y, and or h. So, the log of 4 minus the log of 125. The division of logs is the log of the subtraction of logs. So, 4 is 2 squared, and 125 is 5 cubed. I need a 2 as a base, 3 as a base, or 5 as a base. So I have 2 and 5 as a base. So the power rule, this is the log of 2 minus power rule, 3 goes in front. So this is the log of 3 log 5. And the log of 2 is x, so that's a 2x. And the log of 5 is h, so that's 3h. So that's the log of 4 over 125 expressed in terms of x and h. Now that I have that problem done, let's move on to relating the exponent and the log rules. Recall, the log of a number is the exponent. Note that 3 squared is 9, so the log of 9 base 3 is 2. And the log of 8 base 2 is 3, because 2 cubed is 8. Since the log is an exponent, the log rules are similar to the exponent rules. Let me explain that, because this is the way I learned it when I was doing logs and exponentials first. So the log rules, we have to have the same base. So we have x to the 6th and x to the 5. The bases are x. So in logs, we have a 6, we have an x, and we have a log 5, we have an x. So notice in the exponents, exponentials, we have same bases, x. In logs, we have the same bases of x. Or we could also have 2 to the 4th and 2 cubed. So the bases are 2, so that's 2 and a 4. That's the log of, and we have the base is 2, 3. So this is exponentials, the bases are 2's. This is log, the bases are 2's, because we have to have the same bases when we're doing exponentials. That we're doing logs, we need the same basis. So in multiplication, if we have x to the 6th times x to the 5, that's x to the 6th plus 5, which is x to the 11th. So we're multiplying, we have the same basis, we add the exponents to get to 11. So in logs, if we were doing this in logs, then we have 6 times 5 would be the log of 6, and the bases, say x, that would be base x. So our product would be the sum of the logs. So notice, when we're multiplying, we add, and notice we're multiplying here and we add. This is in exponentials. So when I do logs and I have a product, I have the sum of the logs. So it's very similar to here. Or I could have 2 to the 4th times 2 to the 3. Again, because we're multiplying, we add. So that's 2 to the 7. Now I can change 2 to the 7 to, say, 128, but just leave it as 2 to the 7. So in logs, that would be the log of 4 times 3 when the base is 2. So this is a product. So we have base is 2. We have a sum. Base is 2. So when we're multiplying, we add. When we have a product, we have the sum of logs. So product is add. Again, the log of a product is the sum of the logs. So I'm trying to relate multiplying here to a sum, product here to the sum. And let's look at the division. X to the 6 divided by x to the 5. So that's x to the 6 minus 5. So that's x to the 1, which is x. And if we have a division, so the log of 6 divided by 5 when the base is x is an x. So that's the log 6 base x subtract the log of 5 base x. So when we're dividing, we subtract the exponents. So when we're dividing with logs, we subtract the logs. So again, try to equate. So 2 to the 4 divided by 2 to the 3. So when we're dividing, like bases, notice, like bases x's, like bases x's. So that's 2 to the 4 minus 3. That's 2 to the 1 or 2. And so when we're doing logs, division of 4 divided by 3 when the base is 2. So that's the log of 4 base 2. And division is a subtraction. So it's the log of 3 base 2. Again, when we're dividing, we subtract. And because we have a division, we're subtracting logs. Just keep that in mind, and hopefully everything is okay. So let's put it in as a summary. The log of the product is the sum of the logs with the same basis. This is the product, so that's the log of x base 2. A product is the sum, so it's the log of y base 2. So a log of a product is the sum of the logs. This is a product. 33 could be 3 times 11. So that's the log of 3 base 12 plus the log of 11 base 12. So the log of a product is the sum of the logs. So let's reverse it. The sum of the logs when you have the same basis is the log of the product. Okay, so this is the log. Base is 3. Base is 3, so it's the log of 3. So this is 7 times 5. So that's the log of 5 sevens are 35 base 3. And this is same basis, and we're adding. So the sum of the logs is the log of the product. So it's x times x plus 4. And base is 2. And we could also write that as x squared plus 4x base 2. But when I multiply this out, because this binomial is in a bracket because it's the log of this binomial base 2. Or I could leave it like this. And here we have, again, we have a addition, and we have that's not a base 6, so I can only multiply these two. So that's the log of 6 and 2 times x minus 1. So I can't multiply this because that's a base 10. So that's the log of 10, and that's a base 10. So I can't put that 10 times the 2 to get the 20. So the log of 10 base 10 is a 1. So you got to be careful with that. You cannot say 2 times x minus 1 times 10 because they're not the same basis. So this is a separate one. The log of a quotient is the division. The division of logs in the same basis. So this is a quotient. So we have the log of g, the base is x, minus The log of a quotient division. Quotient is division. No. Is the log of a quotient is subtraction. I don't know why. Quotient is division. So the log of a quotient, which is division, is the subtraction of logs. Sorry about that. There it is. This is a division, so the log of a division is the subtraction of the logs with the same basis. So this is the log, base is 6, and that's 11, minus the log, the base is 6, and that's a 7. So the division is the log of 11, subtract the log of 7. And note, the log of a division is the subtraction of logs. So subtraction of logs, same basis, is a division. So this is reversing it. So this is the log, base is 3, and it's x divided by 71. And this is a subtraction of 2 logs, so that's the log of a division. So the base is 5, so it's an x minus 1 over x plus 3. And this is a subtraction. Notice the base is no base here, but the base is understood to be a 10 and a 10. So that's the log. The log of a subtraction is a division. So that's 9 divided by x. That's the log of 9 divided by x. So just a review of that, just to make sure this is how I learned it. And again, just keep it in mind when you're, the log of a product is the sum of the logs. The log of a quotient is the subtraction of the logs. Same as the exponent rules. And again, if you like my video, click on the like button, click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.